Hello all, welcome to video 2 from section 1.2. Here we're talking about now reduced echelon form. So recall from last time, echelon form means that the matrix, all non-zero rows are above all rows of all zeros. Boom. 2, each leading entry is in a column to the right of the leading entry of the row above it, so that it cascades from top left to bottom right. And then all entries in a column below a leading entry are 0. So furthermore, for a matrix to be in reduced echelon form, we want two more things. We want the leading entries of each row to be 1. So all leading entries are 1. And also we want each leading 1 to be the only non-zero entry in that column. Each leading 1 is the only non-zero entry in its column. Okay. And then maybe now is a good time to ask this question: why echelon form? Why reduce echelon form? Why should I care, Dr. Steinberg? Always a great question. Always encourage people to say, why? What is this good for? And I'll give a short answer now. I'll give a longer answer a little bit later. The short answer is there's lots of convenient information stored in these echelon forms. So lots of convenient information. Stored in an echelon form. I'll put reduced in parentheses because there's information in both forms. And oh, what happened here? Sorry. And we'll have to erase this and write it again later. Oh, let's just, give me a sec. Let me just save this for later. I forgot to write something in. Oh, okay, cut. Okay, and sorry, there's lots of community information stored in this echelon form. We'll prove a little theorem about what that all entails. But then also there's this nice theorem that says, this is our first theorem, theorem 1. It says that every matrix is row equivalent to a unique reduced echelon form. So every matrix. So what does unique mean? Yeah, maybe is row equivalent to one and only one reduced echelon matrix. So maybe you can think of reduced echelon form as like reducing a fraction. So instead of talking about 5/10, you can say, no, the simplest one is 1/2. And so we have maybe this like simplest or most easily understood matrix equivalent to a given matrix. Okay. So maybe I'll have to write that down too. So think we can reduce 5/10 to 1/2. So it's similar to reducing a matrix to its reduced row echelon form. Okay. Right. So then now we've got space to talk about the strategy for actually finding the reduced row echelon form. So let's put that back in. Nope. Here we go. All right. Okay, strategy for row reducing matrix into reduced row echelon form. So first, steps 1 through 3 are just get it in echelon form first. We talked about that in our previous video. Once it's in echelon form, we're going to do two things. We're going to, Oh, what happened to point 5 disappeared? We'll pick up 0.5 in a sec. we'll do one. We'll do two things. We'll start with the rightmost pivot now. So start with the rightmost pivot. We should scale it. Its row. Oops. If necessary. So that the leading entry is 1, and then use this to create zeros above this leading term entry. Use this to create zeros above this leading entry. Okay, we know there are zeros below it already, so that's everything. So then once we've done that with the rightmost, we should continue again with the next to rightmost. So repeat number 4. I'm using the next rightmost leading entry. And that'll do it. Keep on repeating this until you've gone through all of your leading entries. Okay, so let's see an example of this in play. So last time we saw what? That our matrix 0, 3, 4, 1, 0, 1, 5, 9, 2, -1, -1, 1, -1, 0, 1, and 1, 2, 5, -2, 1. We thought this was row equivalent to a regular echelon form, which was 1, 5, 9, 2, -1, 0, 3, 4, 1, 0, 0, 0, -3, sorry. 0, 0, 0, -3, 2, and then a row of all zeros. So this was, yeah, we saw this was echelon form. So we've completed steps 1 through 3. Boom. Let's apply steps 4 and 5 here to continue, to get the reduced row echelon form. Okay, so here we've got our rightmost leading term. So we should scale by -3, or in other words, divide the entire row by -1/3 to get a 1 here. And then use that 1 to kill off these two terms. Okay, so let's got row 3 goes to -1/3 row 3. And that'll give us what? 1, 5, 9, 2, -1, 0, 3, 4, 1, 0, 0, 0, 0, 1, -2/3. And that row of zeros isn't going anywhere. Okay, so now we can use this 1 to destroy the terms above it. So let's take row 1 to row 1 minus 2 row 3. That'll kill the 2 here. And then row 2 goes to row 2 minus row 3. And that'll kill that 1. Okay, so 1, 5, 9. Here we've got row 1 minus 2 row 3. So 2 minus 2 times 1 is 0. And then we've got this annoying little bit of algebra. -1 minus 2 times -2/3 is -1 plus 4/3, which is just 1/3. Okay. And if you're better at arithmetic in your head, then you can do this better than me. It's fine. Okay, 1 minus 1 is 0. 0 minus 2 times -2/3 is... Sorry. We're just doing row 2 minus row 3. So it should be 0 minus -2/3 is 2/3. Okay, and row 3 hasn't changed. And neither has row 4. Okay, so we've succeeded in making this leading entry 1 and getting zeros above it. So we should go to the next rightmost leading term, which is this 3 here. So we'll multiply row 2 by 1/3 to get a 1 there, and then use that 1 to destroy the 5 above it. Okay, so let's go row 2 gets scaled by 1/3. 1, 5, 9, 0, 1/3, 0, 1, 4/3, 0, 2 ninths, 0, 0, 0, 1, -2/3, and all zeros again. Okay, now we want to take row 1 and replace it with row 1 minus 5 times row 2. All right. So 1 minus 0 is, of course, 1. 5 minus 5 times 1 is 0. 9 minus 5 times 4/3. You take my word for this is 7/3. We'll get zeros here, and then yeah, 1/3 minus 5 times -2/3. I hope you'll take my word again. Is -7/9. Sorry. 5 times 2/9. Yeah. We're doing 1/3 minus 5 times 2/3. That's 2/9. Okay, and then row 2 hasn't changed. 0, 1, 4/3, 0, 2/9, 0, 0, 0, 1, -2/3. All zeros. Okay, and now we're done. We've got ones. Oops. Ones in all of our pivot positions, ones for all our leading entries, and zeros of. What happened here? Did I not get rid of that 5? Or did I just rewrite it as 5? I did. I wrote it as 5. It's supposed to be 0. Okay. There we go. Okay, as I said, ones in all of our leading entries, zeros above and below. Sorry, echelon form. Okay, and if you are like I was in undergrad and think algorithms, whatever, I'll just go at it with my own 2 fists and get there somehow. You can do that, but it's much more work to try and just like stare at a thing and put it into place without following a like some kind of formal plan or strategy. So I strongly encourage. I'm not gonna write it. No words done. I do strongly encourage you don't make the same mistake I did. There's a nice plan. It makes life really simple. You can just follow the strategy a few times to get the hang of it, and then it'll be like clockwork. I do strongly recommend the strategy. Okay, and we'll be back for video 3 with more on reduced row echelon form in a sec. Take care, everybody.